Hello and welcome to this demonstration of my loan default prediction application. In this video, I'll showcase the practicality of the application and how it predicts loan default risk using machine learning models. I have already run the necessary files, including the data ingestion, transformation, training processes, and of course the predict pipeline. So among the different models used, I'll focus on the light GBM classifier for this demo due to its high accuracy, precision, recall, and the general performance. However, I have also saved the other models in my GitHub repo, and you can access them. By git pulling, or I don't know how you will access the files, but you can now run them from your local machine and try to see how they perform. So watch as I walk through how the app can assist financial institutions in making more informed lending decisions by minimizing risk. So let us get started. Also, before we get started, let me say that for the categorical variables, I have provided the options that one can have or that are supposed to be chosen from. And then for the variables that have no entries or have no values assigned to them, you are supposed to input numerical values. Remember, if you input a string or a different data type that is not numeric, you'll get an error when submitting, and the error you get, of course, will be telling you that for certain rows or variables you need to input different data types or numeric data types. So let us get started. For this demo, maybe you can say that we want a lady who is aged between 45 to maybe 60 to see whether she qualifies for a loan, right? So loan limit is maybe CF, gender is female, approval in advance, no approval in advance, no pre-approval, loan type maybe type 1, loan purpose you can say maybe P1, credit worthiness L1, all the other variables as chosen. So loan amount, how much do we want her to apply for? Maybe 250,000. Rate of interest in most cases 4%, because the data is based in the in the US market, so maybe you can use that 4% for the interest rate. Upfront, so interest rate spread maybe 1.2. Upfront charges you can maybe 10,000. 10,000 I think. So maybe you can use the 5,500. Term she will repay it in maybe 360 months or maybe 180 months. So what else do you want to input? Not interest only, maybe you can say interest only. Negative amortization, not negative. Lump sum payment, not lump sum payment. Property value, so how much value is her property? Maybe you can say it's 1,300,000. Construction type, occupancy type, secured by home, total units, maybe you can say 2 units. Income, so how much does she make? Maybe in a month she makes, let us say 125,000. Credit type, maybe you can choose one here. Credit score of maybe she has been paying her loans on time and in good shape, so maybe her credit score is quite high, maybe 870. Applicant credit type, age, maybe you can say 55 to 64, right? Or maybe 45 to 54. Submission of application, LTV of maybe 85. Regions, where does she come from or where does she live? Maybe in the northeast. Yes, direct. DTR of maybe 45, and then submit. So as you can see, these are our variables that, and the values are represent what we have input in the previous form. And the prediction result is that unfortunately the client does not qualify for the loan, so the prediction result was a 0, meaning that the client does not qualify for the loan. You can always go back to the form and try to input other person's data. So for this, maybe I can try and share my VS Code to show you how the project runs. And to start with, maybe I can say that There are several folders that are quite necessary for this. So this applies for people who will want to git pull and try to run the models on their end. So what you'll need is the notebook folder. Uh, the notebook folder has the data folder, which contains the low default RISC-V notebook, Jupyter notebook. This is where I had initially done the data cleaning, EDA, just to have a general overview of the data. And then we have the loan default.csv data. This is the data that I have used to do all the analysis, training, and predicting. And the data I got the data from Kaggle dataset. I think I'll also share the link to the Kaggle dataset for you to access it from there as well. And then there is also the source folder, and the source folder has two other folders in it. So there's the components folder and the pipeline folder. So the components folder has the data ingestion, data transformation, and model training files that are crucial for, of course, preparing the data before trying to train and test. And then we have the pipeline. The pipeline contains the train pipeline and the predict pipeline, very crucial for especially they are very crucial. So the pipelines are very crucial, especially when you will be doing this constantly and you would want to automate it. So while you get data from a certain maybe database or whatever source of data you get, and then the cycle of training and predicting is always the same, you know. Other crucial files that we have in the source folder is the logger.py. So logger.py is very crucial when it comes to always notifying you on what is actually happening at a particular time. So like for example, maybe I can try and see the logs that I have and try to see what they are about. So yes, for this at this particular time, I think so entered the data ingestion method or component, read the data set as a data frame train task split initiated, ingestion of the data is completed, all that, and ends with saving pre-processing object. So this logs data is quite crucial when it comes to debugging, as it helps you to know all the processes or what the project or the program has managed to do at a particular time, and you're able to trace where you might have gotten a mistake or where you might have gone wrong. Other crucial files that we have in this folder in the Git repo is the application.py. So this is the application that I have used. It's a fast API one. So of course I got the pipeline, the predict pipeline from from the source folder, pipeline folder, and I called the predict pipeline, which is very crucial in helping us determine or predict whether one qualifies for a loan. So I initiated it, I call it here. And then once our client inputs the data, or once we input client data through the web form, we are able to know whether they qualify for a loan, right? Other crucial files we have here is the maybe requirements.txt. So it has all the libraries that are needed for this program to run. Also ensure that when running, ensure that you pip install the requirements.txt to ensure that the program actually runs using these files. Maybe I can give you an overview of how you can run this file from your end, because I am running it from my machine because I have hosted it locally, and maybe once you download these files you can try and run them from your end or from your machine. Maybe I can open a new terminal to take you through this. A new terminal, it should be a command prompt. So let me activate my virtual environment .script, then activate. So once we are in the virtual environment, we can call the uvcon app load. So it's starting to run, and I think everything will run as expected. without getting so many mistakes or errors. Let us see. So the loan number, so we are back in the to the same page that we were in initially, and this is how it works. So you can input your own data here and still get what you would ideally need to see whether the client actually qualifies for a loan, right? So here I'm just putting different values to randomly to see how it works. So an income of maybe 75,000, credit score of maybe 700. How old is she? 45 to 45. LTV of maybe 78. Region maybe central, maybe of 55. And also doesn't qualify for a loan. That is how this whole program works. And if put into good use, you would of course help institutions in saving a lot of money. So thank you for your time. You can always reach out to inform me on what I should have done better or to ask any form of question. Yes.